In this video, we will demonstrate how variations of pressure changes with depth. We conducted different experiments that will show how those variations of pressure changes with depth. Here are the steps on how we gathered information regarding this topic. The first experiment that we conducted is all about measuring how the pressure changes with depth, wherein we created a device manometer with the use of different materials. We used 2 meters plastic tubes, balloon, colored water, ruler, and the tape. In this experiment, we cut the tube in a portion wherein the length is just enough for our experiment. Then we fill it with the colored water and pasted it in the wall. The water level between the bent tube at the both ends are just equal. Then, we also pasted the ruler between the U-tube manometer. At first, we observed that if the both ends are exposed in atmospheric pressure, the water level is the same. But when we connected the inflated balloon on the other end of the tube, we observed that the water level changes in the tube. This means that when a gas reacts on the water inside the tube, it will change its pressure. This shows how can we measure the pressure change. The second experiment that we conducted is about how pressure changes at different depths. In this experiment, we used different materials: a 1.5-liter empty plastic bottle, cutter, marker, and water. We put 3 holes in the bottle vertically. The first hole is in upper portion, the second hole is in the middle, and the third hole is in the bottom portion of the bottle. We then fill it with water. Then we observe that the streamline of each hole has different distances. The first hole shows a weaker stream than the two other holes. Then while the middle hole has a moderate stream, while the bottom portion hole shows greater stream or long stream. This experiment shows that the pressure increases with depth. As we go deeper, the pressure increases. Pressure in fluids varies with depth due to the weight of the fluid above. This topic is very crucial in understanding underwater exploration, hydraulic systems, and atmospheric changes, whether it is in deep sea diving, designing submarines, or understanding how dams function. The variation of pressure with depth plays a significant role. What is the relationship of depth and pressure? In fluids like water, pressure increases directly with depth. This is because the weight of the fluid above exerts force on the object below, increasing the pressure. The deeper you go, the more fluid is above, leading to a higher pressure. What is pressure? Pressure is a force applied perpendicular to a surface, measured as force per unit area. P is equal to F over A. The pressure at the depth in the fluid with the density is given by the formula P is equal to rho GH, where G is the acceleration due to gravity. What is fluid density? It is defined as the ratio of the mass fluid to its volume. What is depth? Depth is the actual distance from the surface of an object to its deepest point. Real-life applications relating pressure and depth. Bridge construction. In bridge construction, depth and pressure are crucial factors affecting structural integrity and stability, particularly when dealing with water bodies. The depth of bridge foundation, including piles and abutments, needs to be adequate to withstand hydrodynamic pressures from flowing water and to support the weight of the bridge. Pressure flow score, a phenomenon where flowing water erodes the ground beneath a bridge, is also a critical consideration, especially in areas with significant water flow. Submarines underwater. Submarine or sub is a watercraft capable of independent operation underwater. It differs from a submersible, which has more limited underwater capability. Submarines experience increasing water pressure as they descend deeper into the ocean. For every 33 feet or 10 meters of depth, the pressure increases by approximately 1 atmosphere, 14.7 pounds per square inch. Submarines are designed with strong hulls to withstand this immense pressure at extreme depth. Next is Underwater Research Station. An underwater research station is a specialized, pressurized habitat deployed underwater, designed to allow scientists and other personnel to live and work in a submerged environment for extended periods. These stations are equipped with life support systems, research laboratories, and living quarters, enabling scientists to study marine ecosystems, conduct experiments, and explore the underwater world. Building a strong underwater station. Underwater structures requires material that can withstand pressure underwater, corrosion, and harsh marine environment. The important materials in construction include concrete, especially high-strength or self-compacting concrete, steel, often enclosed in a concrete for reinforcement, and materials like acrylic glass for transparent structures. Geopolymers, which are environmentally friendly and strong, are also emerging as viable options. The concept of buoyant force has also impact in this scenario, since it applies the sinking and floating of an object. Since this underwater station will be located at the bottom of the sea, it must be well planned and well constructed to avoid accidents and damages that pressure can cause. The Pascal principle stated that any change in pressure applied into a completely enclosed fluid is transmitted undiminished to all parts of the fluid and enclosing one, meaning the pressure applied will be transmitted the same and not changes. This principle can be applied to real-life applications such as hydraulic lift system and hydraulic brakes, wherein it uses the pressure applied to an enclosed fluid or pressurized fluid to be able to lift a car and also to be able to slow or stop a vehicle.